Alright, so I'm going to title these notes Radioactive Decay. So when you start to process this, what do you think when you think of the word decay? What does that mean? Okay, so sometimes to die. Where do things decay that you can think of, like in your normal experience? Skin cells decay. Okay, what about in the forest? Like it's fall, the leaves are falling. Do they just stay there forever? No. What happens to them? They decay. So when they decay, what happens? Somebody in an earlier class used the word decompose. Or to fall apart. Why does a leaf fall apart or decompose or decay after it falls off the tree? Okay, it has no life source. It's not getting resources. It cannot sustain itself anymore. It's not able to maintain. All right. Radioactive. This word right here has the same root word as radiation. So what does radiation mean? Let's use it in another way. Warmth radiates from the sun. Warmth radiates from the heater. Your smile radiates in the room. What does that word mean? People say to radiate positivity. Give off. All right, there we go. Radiation gives off. Send away, put out into the world. Okay, so we kind of thought about these words. I want you to think about one more word and then we'll really start talking about this concept. Stability. I know we're in chemistry class, but like, what does stability mean? You don't have to think in terms of chemistry. Huh? Balance, okay, so balance maybe is what we think of. What's another word? I can't hear, somebody just whispered something. Strength, okay, so stability is sometimes strength. We all want our finances to be stable, right? What does that mean? Consistent, okay, there's another good word. This is kind of a weird way to think, but what about, give me a thumbs up if you think this works. Okay, able to maintain. Able to hold it together. Does that work? Okay. We all want stability. Everybody does. That's one of those like hierarchy of needs sort of things. We all want stability. We all need stability. And atoms are a lot the same. Atoms need to be stable in order to just exist. We'll talk about that a lot when we talk about bonding. Sometimes chemical bonds will create stability in an atom. But are atoms always stable? No. neither are people either. And so we'll kind of could use an analogy between people and atoms. But I know I probably shouldn't put this on record, but sometimes, I don't know if you guys ever feel like, do you ever feel unstable? Maybe. I know I feel unstable sometimes, and I just want to throw stuff. Like, maybe throw rubber bands or throw something. Ever feel like that? Well, that's what an atom feels like too. An atom feels like it's unstable. It throws things. So, unstable, I'm going to put that in kind of quotes, okay? Alright. And that's exactly what an atom does. An unstable atom will throw things. So I'm going to write that sentence so that we're really clear. Now, at my desk here, I have rubber bands and gum wrappers. You might have stuffies in your room, or, I mean, okay, my 7-year-old has stuffies she throws in her room sometimes. But what kinds of things does an atom have that it might be able to throw when it feels unstable? Remember, this is just an analogy, but I think an atom doesn't have very much. An atom has protons, neutrons, electrons, and energy. So that's the only things that it can throw. You can only throw what you got. So there's some combinations that these things get thrown in. Okay, so that's going to be a title. Things that an atom can throw. The first thing that an atom can throw is an alpha particle. An alpha particle is the biggest one, so we might note that. It's also the easiest to stop. An alpha particle can be stopped by a piece of paper. So what is an alpha particle? An alpha particle is actually 2 protons and 2 neutrons. If I wanted to write that in proper form, I see I have 2 protons, so I know that would be the atomic number of my particle. What would the atomic mass of this particle be? So protons plus neutrons is 4, right? What element is number 2? Helium. So an alpha particle is actually a helium atom. It's a pretty big thing to throw out because you're cranky. Alright. So let's think for just a second though. If this cranky element loses 2 protons and 2 neutrons, what happens to the nucleus of the cranky element, of the radioactive element? Is it still the same thing? No, it lost 2 protons. So it changes its identity. This thing comes from the nucleus and changes its identity. Alright, another thing that an atom has to throw is a beta particle. Now this one's a little weird. Just throwing that out there. A beta particle, get ready, this is a little crazy, is like an electron from the nucleus. Now you're sitting there thinking, wait a minute, electrons are outside the nucleus. That is absolutely true. So what actually happens is, we're going to explain this, okay? A neutron becomes a proton. So that negative stuff that balanced out the neutron gets thrown out of the nucleus. The neutron becomes a proton. And so that actually looks like this, because we have to have a symbol for it when we display it. It has a mass of 0 and a -1 . So notice what's going to happen to your nucleus. Your cranky particle, one of its neutrons becomes a proton. Is it going to change its identity? Yeah, and we're going to practice that here in a little bit. And then, you guys ever heard of the Hulk before? Aw, you guys aren't telling me you never heard of this. You know, the giant green guy who's supposed to be able to grow green every time he gets mad. He is supposed to be shot with gamma emission. Weird, right? This one, I want you to note, is the hardest to stop. So you have to have like a lead wall to stop gamma emission. And the crazy thing, this kind of counterintuitive, is that gamma emission is really energy. It's just energy. The nucleus doesn't change. So you might put a note on that. Nucleus does not change. And a symbol for gamma emission, it doesn't have any mass, it doesn't have a proton, so it doesn't have an atomic number, and it is actually the gamma symbol. Okay, so a lot of times it looks like a squirrely capital Y. Okay. So while alpha particle and beta particle, there's actually something coming out of the nucleus. In gamma emission, it's just energy. It's not a particle. That's why I put emission, just to be clear. There's a couple other kinds of emission that we don't really need to discuss, but positron emission we'll take a couple notes on, just so that you know, because I think there are questions on the CK12 about this. Oops, I misspelled that. And I did it up there too. So positron emission. And this one, a proton becomes a neutron. So this is weird. You get a positive, it's kind of like a positive electron from the nucleus. Now wait a minute, electrons are negative, right? So let's explain that a little bit. A proton becomes a neutron so we lose one proton, and the symbol for that is 0 + 1 E. So that's a really weird thing. We don't actually have to that won't be on your test or anything. That's just when you come across it in different ways, you might just want to know what you're talking about there. But these three, alpha particles, beta particles, and gamma emission, those will all be things that you'll have to answer questions about in the practice and as we go on.